Hi, I'm Jesse with Mastercam. In this video, we're going to look at how to create a remachining toolpath in Mastercam for a part that needed to be repaired. We'll also look at how the Haas wireless intuitive probing system will help us relocate the part when it's time to run the toolpath. Every shop strives to create perfect parts every time, but even the best in the business will have an accident now and again. In the case of our example part, this gouge was created by a retract height that wasn't properly set. Since the programmer didn't review the toolpaths and verify or machine simulation first, they weren't able to find this issue before it happened at the machine. When this sort of thing happens, it's common practice in many industries to send the damaged part out and have the affected area welded. Once the weld repair is complete, the part needs to be set back up in the machine so the weld can be remachined, returning the part to specification. The combination of the tools in Mastercam and the functionalities of the Haas next-gen control make this process fast and easy. Let's start by looking at the original file that was used to machine this part. Inside the file, you'll notice that there are a few roughing operations that are immediately followed by stock models. This serves two purposes. First, the stock model can be referenced by toolpaths. This means that Mastercam will create a rest machining operation that does not contain any additional or unneeded tool motion, since the toolpath knows what stock is left to cut. Secondly, the programmer can toggle these stock models on and off, which is a helpful way to visualize the state of the part. This can help inform decisions that are made about what toolpaths could or should be used to continue processing the part. After those roughing toolpaths is a multi-axis parallel toolpath. This toolpath finishes the top face of the part, which happens to be where the repair is. For the remachining of this repair to blend in the best, it's a good idea to utilize the same toolpath motion. In this case, we're going to end up making a duplicate of the original parallel toolpath. Obviously, we don't want to just rerun the exact same operation, since we don't need to recut the entire face. Instead, we'll isolate the area of the part that needs to be machined so the toolpath can be as efficient as possible. Ideally, you would have access to tools like a Master 3D gauge with the optional scanning head. This would allow you to scan the part after it was repaired and use the resulting mesh to create drive surfaces that perfectly match the area to be machined. Of course, that's not always an option. For this example, we'll simply create some geometry in Mastercam that will allow us to isolate the welded area. What we've done is create a simple spline that describes the outside boundary of the area we need to remachine. This boundary isn't critically accurate, but it should be enough for a simple repair. Instead of creating a new toolpath from scratch, we'll create a group below all our other toolpaths, then make a duplicate of the parallel toolpath we looked at earlier. Since all the original toolpaths are linked to the existing model, if we make any changes to this model, it may break links to those toolpaths. Instead, we'll make a duplicate of the model onto a new level and use that for our repair work. Once our duplicate model is created, we'll go to the Model Prep tab and launch Split Solid Face. When prompted, we'll pick the top face of the model and spline. The spline is projected down onto the face and used as a boundary to split the solid face with. This means we now have a separate face that perfectly describes the area we need to remachine. Now that we have that face isolated, we're going to create a stock model from it that can be used for our rest machining. To do this, let's start by creating a surface from this face by using the Surface from Solid command. Next, we'll launch Stock Model from the Toolpath tab. We'll name the stock model and pick the surface as the initial stock shape. Next, we'll change the stock model color to make it easier to see in the part file. Lastly, we'll leverage the additional offset feature. To find our offset value, we'll take measurements of the height of the weld bead. making sure that we have an accurate measurement at its highest point. Once we enter that value and close stock model, we can see that the new Weld Repair stock is displayed. It can be toggled on and off by pressing T. Now that we have a stock model for the Weld Repair, it's time to make some adjustments to the parallel toolpath to make sure that it's using this stock model as the reference for what to cut. First, let's adjust the drive surface offset to 2000s. This will leave a little material on the part, which is always a good idea when remachining. It allows you the opportunity to slowly adjust the toolpath to sneak up on a good blend with the existing part. On the stock page, we'll enable stock and choose the Weld Repair stock model as the source. Because this part is going to need to be remounted in the machine, we're going to need to be able to locate it during our part setup. Our original G55 plane might not be ideal for this, so we'll create a new plane called Rework G55 that will allow us to pick up the part location from one of the hole features on the part. We also want to make sure we set this new plane as our WCS, tool, and construction planes. We can now regenerate the toolpath. Note how the toolpath is limited to the area we need to cut, and if we turn on the display of the original version of the parallel toolpath, the stepovers line up exactly. This Weld Repair might be a little too much stock to take off in one pass. Let's go back into the parameters, and on the roughing tab, enable depth cuts. We'll set the number of cuts to 2 with a spacing of 20 thousandths. With the toolpath regenerated a second time, we can review it in backplot. The tool does not look overly engaged in the material and should be ready to go. Let's post out the code and get the part set back up in the machine. Let's start by loading the part back in the machine. Next, we'll manually call up tool 41, which is our probe. We'll go into MDI mode, type T41, and press either ATC reverse or ATC forward. Once the probe is in the spindle, we'll jog the probe over and down inside the approximate center of the locating bore that we chose as our G55 location in Mastercam. Now we'll press the offset button and navigate to the work tab. Highlight G55 and press F3 for probing actions. In this case, we can use the bore cycle. After pressing enter, we'll enter the bore diameter of 0.625. That will populate a macro that I can run in MDI by pressing cycle start. This automatically populates the G55 work offset with the correct X and Y values, but we still need to set our Z. We'll do this by using the single surface routine. Picking up a part location doesn't get much easier than that. Now all that's left to do is load the program and machine the part. We hope you've enjoyed this quick look into setting up a remachining toolpath in Mastercam and using the wireless intuitive probing system in your Haas Next Gen control. And remember, this process isn't just for multi-axis machines. This same process can be used on any 3D toolpath as well.